Hello guys, hope you're doing well. I'm Said and welcome back. In this video, we'll solve 4 integrals that look scary at first, but each one breaks down with one smart idea. Let's start. Number 1, I is the integral of arc sine of x plus x over the square root of 1 minus x squared dx. It looks a bit intimidating at first, but the secret here is to break it down. We have two terms in the numerator, so let's split this into two separate integrals like this. The integral of arc sine of x over the square root of 1 minus x squared dx plus the integral of x over the square root of 1 minus x squared dx. So let's start with this integral. This is all about pattern recognition. Look closely at the denominator. Do you see it? The derivative of arc sine of x is exactly 1 over the square root of 1 minus x squared, right? So if we let u is arc sine of x, so du equals 1 over the square root of 1 minus x squared dx, right? So the first integral becomes the integral of arc sine of x over the square root of 1 minus x squared dx equals the integral of u times dx over the square root of 1 minus x squared is du. If we use the power rule, we have 1/2 u squared plus c, or 1/2 u is arc sine of x. Arc sine of x squared plus c. Now let's move to the integral of x over the square root of 1 minus x squared dx. So we have the integral of x over the square root of 1 minus x squared dx. So let's u is 1 minus x squared, so du equals negative 2x dx. Since we only have x dx in the numerator, we just need to move that negative 2 over. So all we need to do is multiply and divide this integral by negative 2, right? So we have negative 1/2 the integral of negative 2x dx over the square root of 1 minus x squared dx, right? So we have negative 1/2 the integral of negative 2x dx is du, and u is 1 minus x squared, so over the square root of u, right? So we have negative 1/2 the integral of the square root of u is u to the power of negative 1/2 du. If we use the power rule, we have negative 1/2 times 1 over negative 1/2 plus 1 u to the power of negative 1/2 plus 1. So we have negative 1/2 times negative 1/2 plus 1 is positive 1/2. So 1 over positive 1/2 is 2 times u to the power of positive 1/2 means the square root of u. So final answer is negative the square root of u plus c. And as you know, u is 1 minus x squared. So we have negative the square root of 1 minus x squared plus c. Right? So final answer is the integral of arc sine of x over the square root of 1 minus x squared dx is 1/2 times arc sine of x whole squared plus c, and the integral of x dx over the square root of 1 minus x squared is negative the square root of 1 minus x squared plus c. So final answer is 1/2 arc sine of x whole squared minus the square root of 1 minus x squared plus c. Number 2. The integral of x squared times cosine of x cubed plus 2 dx. We have x squared multiplying the cosine function. The function inside the cosine is x cubed plus 2. So let's choose that as our u. Means u equals x cubed plus 2. So du equals 3x squared dx. Or 1 over 3 du equals x squared dx. So the integral becomes the integral of x squared cosine of x cubed plus 2 dx equals x squared dx equals 1 over 3 du, and x cubed plus 2 equals u. So we have the integral of cosine of u times 1 over 3 du, right? So we have 1 over 3 the integral of cosine of u times the u. And as you know, the integral of cosine of u du equals sine of u plus c, and u is x cubed plus 2. So final answer is 1 over 3 sine of x cubed plus 2 plus c. The integral of 2x plus 5 to the power of 12 dx. We could expand 2x plus 5 to the power of 12, but that would take forever. Instead, let's use u substitution for the expression inside the parentheses. Let u is 2x plus 5, so du equals 2 dx, right? Or dx equals 1/2 du. So the integral becomes the integral of 2x plus 5 is u to the power of 12 times dx is 1/2 du, or 1/2 the integral of u to the power of 12 du. And if we use the power rule, we have 1 over 12 plus 1 u to the power of 12 plus 1 plus c, right? So we have 1/2 times 1 over 13 is 1 over 26 u to the power of 13 plus c. And we know that 1 over 26 u is 2x plus 5. 2x plus 5 to the power of 13 plus c. This problem shows that even with large exponents, if the function is linear, u substitution simplifies the integration beautifully, right? The integral of ln of the square root of x over x dx. First, a quick look property. Ln of the square root of x is the same as ln of x to the power of 1/2. We can bring that 1/2 out. So it become 1/2 ln of x, right? So we have the integral of 1/2 ln of x over x dx. Since 1/2 is a constant, we pull it outside the integral sign. So we have 1/2 the integral of ln of x over x dx, right? Let u is ln of x. If we take the derivative of both sides, we have du equals dx over x. So the integral becomes the integral of 1/2 the integral of ln of x is u and dx over x is du, right? If we use the power rule, we have 1/2 times 1 over 1 plus 1 u to the power of 1 plus 1 plus c, right? So 1/2 times 1/2 is 1 over 4 u squared plus c, and as you know, u is ln of x, ln of x squared plus c.